Lesson 15 of Module 4 is using the quadratic formula to find the discriminant and use it to determine the number of roots. So just background, number of roots. Remember, roots is another word for the solutions of the quadratic. The x-intercepts, right? It's where that U or that N shape crosses the x-axis. So the discriminant is a new vocabulary word, which you should probably take notes on, which we're going to talk about in a second. But it just says a do now. You're seeing this, and it's done for you, but I'm just going to talk through some of these, and I'll do one with you guys towards the end. But we always want, before we solve using the quadratic formula, we always want it in standard form, which is the ax squared plus bx plus c. And as you look at this equation right here, we have a lot of terms on both sides of the equation. So we need to move things around to get it looking like the ax squared plus bx plus c, which is where you see it here. The 2x right here is where we get it. So that's your, prior skill of being able to move the terms around using the inverse operation, adding and subtracting on both sides to get it looking like a nice 2x squared plus 8x plus 3 right here. And it's equal to 0, right? We're allowed to have that equal 0 on the right side. And then solving the quadratic formula, we use our formula, which again, you wouldn't have to memorize for the Regents if you were taking it, but have it in your notes. You don't have to look around, but it is here, negative b plus or minus the square root of b squared minus 4ac over 2a. This is like a really good go-to one to find roots. It's always going to work as long as you know how to, interpret the roots that you get and be able to solve for both. And as we've been going on, I've told you guys that you always want to look for two roots, where it crosses the x-axis twice, because it makes that U shape. We're really used to looking for it like that, but today you're going to realize that sometimes you don't have that. So like if you look on GeoGebra, which is a really good tool I like to use since we're online, a lot of the times we get something, whoa, I don't want that, that looks like this. And if we plot this, where is it? So if you see this quadratic here, it's kind of in the air, right? Is it actually even crossing the x-axis? And will it ever? No, it's infinitely going to go up and get wider, as you can see. So does this graph have any roots, or does it have solutions? No, because it doesn't cross the x-axis and never will. So there are some graphs where, and you can always use your graphing calculator or use GeoGebra to check whether or not your graph will cross the x-axis. But something like this won't. And, we're going to do more on sometimes it will cross once, sometimes it cross multiple times, twice. Maybe it'll cross, so it'll cross 0 times, 2 times, or 1 time. And we're going to look at some examples where it will do those things. All right, so here in the do now problem, when we do solve with the quadratic formula, we do get negative 4 plus or minus radical 10 divided by 2, and that is something you can solve, and you do have an answer. You do get two answers for that one because you have a plus and you have the minus. This number right here, this radical 10, is called the discriminant. So the discriminant is that number actually under the radical, which we're going to talk about right now. So the number under the radical symbol in the quadratic formula is called the discriminant. It tells us about the nature of the roots of the equation. So on the Regents, they would have given you a multiple choice problem, and just as an example, and so can I, obviously, as practice, because you're going to need this for Algebra 2. Just looking at like this setup right here, the negative 4 plus or minus radical 10 divided by 2, just by looking at it, you can tell me how many roots there are. And it's a great little technique to have because you don't have to do more work, right? The purpose of algebra really is to utilize your tools and utilize your foundational skills so that you don't have to do more work than you kind of need to. And, a lot of teachers won't tell you that, but like that's the nature of algebra. There are a lot of tricks, and I don't want to say tricks, but there's just a lot of ways to interpret the math where there could be less work for you. And some people might have to do the extra work just to understand it, and that's totally fine. But for those who are quick with it, This is just really one of those aspects where it'll be much easier for you to interpret. So again, looking at that radical, you will be able to tell what the nature of the roots, meaning how many roots there are, or what is happening. So just an example, I give you an equation. I say solve using quadratic formula, meaning find me the roots, right? If I ever say solve using quadratic formula, you're finding the roots. Where does it cross? Where does this quadratic cross the x-axis? What are the solutions? What is x equal to for this quadratic? So when we do the quadratic formula and you're realizing we get x equals 2 plus or minus the square root of 0 divided by 2. So the square root of 0 is just 0. So this plus or minus radical 0 does not really affect the answer. So when we simplify, we get 2 divided by 2 equals 1, meaning it's not one solution. It means x is 1. So if you're looking at the graph here, the graph is actually only crossing at one spot at x equals 1. So if you want to think about the rule, if you have a radical 0, what does that mean about the nature of the roots? How many roots are there going to be? Well, according to the graph, how many roots are there going to be? How many times is it going to cross the x-axis? Only once. Okay? So if you ever see a radical 0, you know you're only going to have one solution. Let's look at number 2. We solve using the quadratic formula, plugging in our numbers. You guys were good with that last time, so I don't think I need to go over the process, but we'll do one later together. When we do this process out, I get a -4 plus or minus a radical -80 divided by 6. Okay, and if I'm looking at you already see the answer, there's no real roots. Well, why is there no real roots? Well, if we graph this, the quadratic formula is kind of dangling in the air, like we saw when I did on GeoGebra. Meaning it's not ever going to cross the x-axis, which means can there ever be a root? Can there ever be a solution? No. So for this one, there actually is no solution. There's no value that we can plug in for b to make this equal to 0. That's basically what it means. If I were to pick a number and figure out what b value is going to make this equation equal to 0, there is none. It's not going to happen. Based on the graph, based on my math, there's so many ways to prove that it's not going to happen. So basically, if we get what under the radical, we're going to have no real roots. What's different about this one than the other ones? So basically, if we get a negative under the radical, it means no real roots. And actually, if you put a negative under a radical in your calculator, it's going to tell you there's an error. And you're going to learn about imaginary numbers in Algebra 2, and that's where this connects your knowledge to. Okay? And this one, we do the quadratic formula. It's already in standard form. Plug in the numbers. We get radical 81. That's a positive, nice number. It's actually a perfect square. Radical 81 is 9. You will get 2 solutions based on the graph as well. It does cross nicely at 2 places. So pretty right here. Okay. All right. So basically, if you want to write the summary in your notes, this is a really good summary. When the discriminant is a positive number, these are basically the rules. If the discriminant or the number of the radical is a positive number, there are 2 real roots. The parabola hits the x-axis 2 times. If the positive discriminant is a perfect square, then the 2 roots are rational. Okay, meaning they're a real number. Okay, if the positive discriminant is not a perfect square, then the 2 roots are irrational. All right, so like we saw before, it was a radical 81. So we got a really nice numbers. We got -4 and 1/2. Those are, those are rational numbers. When we get something like here, where we get 1 plus or minus a radical 2, if you put radical 2 in the answer, you're going to get a repeated decimal. Going to be irrational. All right. So there's a difference between if it's